Good afternoon, welcome. My name is Jussi Pakkanen. I'm the lead developer of the Meson build system project. And today I'm going to be talking about stuff we learned porting the LibreOffice's build system to Meson and things adjacent to that. Oh, no, I'm using this one. Oh. Is the voice picking up okay? Yeah. Okay, good. Okay. So, even though it says LibreOffice, this is a lot more than that. It's an amalgamation of a lot of different projects I've done over the years. I've done build system conversions for many proprietary projects and also open source projects, one of the Godot game engine. Also the Open 3D game engine, which I did as like a test to see how it works. This is the one from Amazon. I also did a test for Unreal Engine and a bunch of other projects as well. And these all kind of mingle in together, but there's been many different kind of very large projects. Some of these are not completed or they haven't been adopted by the upstream and they've been just mainly experiments. But others have been. So the main question I'm sure you all have in your mind is like, why would you care about Meson? Because it's some weirdo niche thing that no one uses because we have other things, which are the standard ones. But let's look into this. So this is a good question. So let's look at a very specific example, namely this thing in here. So this is the Steam Deck by Valve. And if you look at how it's actually built, so the core of any game engine or like platform is like that, is the 3D graphics stack. And this uses the Meson 3D graphics stack, which is an implementation of OpenGL, Vulkan, the user space parts of the device drivers and all of that. And Meson is built with Meson. There are other parts in the 3D graphics stack as well. So there's DXVK, and this is an implementation of DirectX on Vulkan. And this is also implemented in Meson, or built with that. Then there's the input stack, so how keyboard events and all those are handled. This is using a library called libinput, which is again on most Linux systems, and this builds with Meson. For windowing, there's Xorg and Wayland. I think it uses both, but both of these build with Meson. And Xorg one also builds on Solaris with Meson. So if you are using Solaris, there you go. And this audio stack, it's Pulse Audio, which, as you can probably guess by now, it builds with Meson. The init system is systemd, which also builds with Meson. And more interestingly, so there's the application install stack. So there's the Steam games, which come the way Steam runs things, but you can also install additional applications. And this is done with a system called Flatpak. And Flatpak is built with Meson from scratch. There are other features as well. So we have dependency management, because every build system needs to have a dependency management story. And there's a web service called WrapDB where you can download stuff. So as an example, suppose you want in your project you don't like stet unordered map, it's too slow, you want to use something fast, and you want to use the Abseil C++ containers. So the things that you need to do in order to use it, there are two things. First, you run this command in your project root, which contacts the service and downloads all the things that you need to build Abseil. And then inside of your project file, you'd say this, dependency Abseil container is the magic word, and then you get a dependency object which you can use to pass around and put in your targets. And this is it, this is all you need. There's no external things you need to install, there's no third-party dependency managers and all that. And in the WrapDB, the idea is that you want to make it as easy as possible to download dependencies and use them, but do not mandate the use of WrapDB. So the big problem with many package managers and build system and dependency managers is that they are very strict that there's only one way in which you get dependencies, and this is the thing that we have. And trying to use other things together is very difficult. Most don't support that. If you want to have your own WrapDB, you can host. It's just some static files, put them inside of your firewall, and there you go. And even more importantly, it works transparently with system dependencies. There's a big battle on whether you should build your own dependencies or whether you should use system dependencies. And this battle has been going on for like 30 years or so. It's not gonna stop anytime soon. But so we as a build system say, okay, we support both. We support them natively, and we support them with the same syntax. So your build files don't care where your dependencies come from. You just say that this is what I want, and then things happen. Currently, we have something like 150 packages, things like SDL2, graphics libraries, and so on. There are 1.3 million downloads the last time I checked. Interestingly, the most downloaded package is OpenSSL. So if you have a thing that you build, something you build on Windows and you need OpenSSL, and you don't want to wrestle with the Perl monstrosity that it has, here's an alternative. I see some smiling in the audience. Good, good, good. But enough about advertising. Let's get to the actual content, and that's LibreOffice. And LibreOffice is big. It's really hard to comprehend how big it is. So here's an audience participation question. The first person to get the answer correct wins this wonderful mug. Only 200 have ever been made. You can only get one by me giving it to you. So the question, LibreOffice has 113,000 lines of what? Some sort of content. What content? No. Makefile? Yes. Correct. There you go. Congratulations. So how many have projects that have fewer lines of C++ than this? Yes, there you go. So it's incredible. The joke that LibreOffice developers have is that LibreOffice breaks every tool it's ever used with. And it's one of the largest open source C++ code base in the world. So the original talk said it's the biggest. Well, let's look at the details. So there's this web service called openhub.net. And they do this, they provide statistics on how big different things, different repositories are. So according to their statistics, it's 5.8 million lines of C++. I went through some of the statistics trying to find the biggest one that there is. And the one I found was Chromium, and that's 12 million lines. For comparison, Qt is 5.5, LLVM is 5.9. When I submitted the talk, it was fewer than 5.8. So, but they grow bigger faster than LibreOffice, so they surpass them in the meantime. Oh, that's my theory anyway. Boost, 4 million lines. But this actually it's a bit difficult to compare these because Chromium has a monorepo, so have all of their stuff in one repository, whereas the other ones have just their own. So it's hard to know how they're actually calculated and what things are. But if you do calculate dependencies, LibreOffice uses Boost, so that's 10 million already. And you can also build it with a Qt 5, so you have 16 million lines of code there. And all the other things as well. So the thing that then we find is that if you have a big system like this, changing the build system is a major engineering challenge. It's just not something you just do and get on with life. You need planning, you need design, you need a rollback solution in most cases. Now, if your project is small enough, then it's possible to, you just do it and it's there and then you move on in life. But past a certain size, this just doesn't work. And you also need buy-in from other people in the team because if they don't want to help or they don't want the new system, you're going to have a challenging time. And there are actually multiple different phases that you need to go to make this happen. And they have different requirements on what you need to be able to do to make it happen. So let's go through with them. So we start with stage number 1. And this is the preparatory work that you need to do. So let's start by looking at Hofstadter's law, which is about estimation and says that it always takes longer than you expect, even when you take into account Hofstadter's law. And there's a different version of that, which is Hofstadter's law as applied to change management. And it says that people will resist any and all change more than you can possibly imagine, even when you take into account Hofstadter's law for change management. People will resist everything that you can possibly... I could tell you stories, you wouldn't believe them, but you'll hear some of them. So let's look at one. This didn't happen to me, this happened to a coworker of mine. But I stress, this is an actual true fact which happened. So they had their old build system, and it wrote executables to this directory. It's builder bin, and this is on a Linux machine. And the new one wrote them in the root of the build directory because that's where they were defined. And this alone was sufficient reason not to do the switch. It's like, no, we can't do that because this is too big of a change. Again, not a joke, this actually happened. And these are sorts of things that you're gonna be facing. Now, there is a silver, poker face is a good thing because you will face unexpected and interesting claims, and you want to be prepared for that and not be taken by surprise. There is a silver lining, as in most things, is that if you can make development life easier for people, after a while they stop complaining and they're actually quite happy. But you need to get past this certain hump. Here's a real-world comment that was given to me, and it goes like this. They had used Auto tools for a long time, and then they did a switch. And they said that they had to go and make a bug fix release on the old branch. And it still used Auto tools. And it's like, I never realized before that it was that bad. And this is a very indicative comment of you get used to things which are terrible and you don't think they're terrible, but in hindsight, maybe they were. Okay, so the skills you need in this phase of the operations is mostly diplomacy, because it's about convincing others on that the change should happen and how it should go and where it should end up. Presentation, if you have experience in selling used cars, that's good. Conversational judo is actually quite interesting because you're going to have people who are going to come at you with very strong opinions and present them very strongly, and you need to gently deflect them to the side and use their own power against them. Because if you just be blunt and talk to them, it's going to be a clash and it's not going to be nice. And basically you need to be like the champions, like be the change you want to see in the world and all that. And it's like you have to be the one driving it because probably no one else is going to be. All right, so let's look at stage 2. Get a sip of water. And this is the first stage of the actual porting work. So you have the configuration which you need to do. So let's look at a typical vintage build pipeline that you have. So you start with the source code, which you have, and then you feed that onwards to Cthulhu, and then you get out your binaries. And everything is fine as long as you don't look in the middle for too long, because it will destroy your soul. Are there people here who have this set up at their projects? Yes, indeed. But then, what about documentation? Sure, like you could just look it up and see how things work. Well, yesterday I did some touristy things. So I climbed, or no, not climbed, I used the elevator to get up to CN Tower. And there was a vending machine. And I took this picture because it perfectly describes the state of documentation in typical build setups. At the top we have the specification documentations, which is very clear. It says no cache accepted. And then at the bottom we have the implementation documentation that says cache only. And then the question is, which one of these is correct? It's like, well, that's the implementation. That's the thing that actually takes the money. That has to be the thing that's correct. And it's not. It's the one at the top. That's the correct thing. And this is about the state of documentation that you can expect. So here we come to like the most important guideline when you try to understand how an existing build setup has been implemented. And it goes like this. Don't. Like, no, seriously, don't. Don't even look at it. Because the things you find can be quite unnerving. Let's look at an actual example. So this is a CMake script from a source which shall remain unnamed. So it starts like this. So you have set sources, okay. You have source 1, source 2, okay. Looks fine up to now. And then you have this. And what it does is that it uses regular expressions to add src/ to all of these source files, I think. And then it sets that in the parent scope. So what they have managed to do is to have automate a thing that doesn't need automation, which is more complicated than just having the source texts in the source files. And this is on the lighter side of things, because if you get a slightly more complicated example, then you have this, which raises interesting questions, such as, number 1, what does it do? Number 2, how does it actually do it? And number 3, how many processes does it spawn to do its thing? Just left as an exercise to the reader. So if you're not going to look at how things are doing, what are you going to do? And here we're going to actually cheat. So when you build source code, it's fully determined by the compiler and linker invocations. That's the thing that actually matters. So what you do is that you run make or whatever the build tool that you have in verbose mode, then you scrape the output, and then you can get the compiler flags and everything else that you need, and then you re-implement that using the new build system. And this is usually a lot easier to do because compiler flags don't lie. It's like they're there and you can see exactly what's happening, and usually there's an underlying thing how it works, and it's very easy to get from the compiler invocations as opposed to trying to understand what the code is doing in the build system. There's a lot of garbage that's possible. There may be like tens of compiler flags for defines that are not actually used or other things that just come from somewhere that no one knows, but you just filter that out. And you do the same thing for configuration headers. Typically what they're supposed to do is that you have an autocont or a CMake. You find you have like CMake define something, and then you run the replacement on that. But it also can be slightly more difficult. You can have self-modifying macro code so that your generation template is just a string of like line noise, and then it gets generated into something that has the thing. But if you take the output of that and you convert that to a template, then it's simple because you know this is the thing that needs to come out, and then you can just generate the same thing in a much easier way. But then now you have the basic structure and you have the beginning. So let's look again at an example from LibreOffice. It's implemented in a very 90s OO framework. It's called UNO. I think it stands for Universal Network Objects. And they are objects, but they're not universal, and there is no network. But other than that, it's fine. But it's basically like a re-implementation of the Java object model in C++, but it's implemented in kind of a C way with void stars, which is all the fun in the world. So if you want to instantiate an UNO object, you need a registry. And the registry requires that you have your files in very specific locations, and you have like shared objects, and you have configuration files and so on, and they need to be relative to each other in a very specific way that mimics the way that's going to be installed in the final executable way. But if you don't have that, then it doesn't work. But fortunately, it has validity checks. So if it cannot do the steps necessary, you get the registry, you get an error, it throws an exception with a description of what happened. But if these setup is wrong, then you get an exception that the framework can't be instantiated, but then it tries to use the framework to print the object, the framework which is not instantiated. And this corrupts the stack. So when you run this program, you get an immediate failure, which has no output, no logs, and if you use GDB, you get a row of question marks and nothing else. So, and then this is the sort of things that you get to debug. And for code generation, so LibreOffice has a lot of it's a lot of XML in it. Basically everything in it is XML, and there's tooling to do XML manipulation, and they build generator files that then they use to generate source code from XML. And as before, this would require that you have the registry and everything set up because it uses the shared things. Except, and now we get to the second question, audience question. So after a deep dive in the code, you find that the source generation from XML to C++ is actually done with what? Any guesses? It's not Make. While you think, I'm going to give one for the volunteer for great work, but not Make.
Is it Perl?
Very, very good, but not. You're in the right area. Yeah, very, very close. So what other tools are there in the Unix userland for data manipulation or text manipulation?
Not at all.
Yes. Right. So there are at least 4 different XML parsers in LibreOffice codebase, and one of them is awk. Because as we all know, XML is line-based, and you can parse that with regular expressions. So these are things. So a portability thing to consider in projects in general. So if you have native code generated binaries, consider replacing them with Python scripts for the same thing. Because like reading text files and manipulating that and writing out text files is something that Python is really good at it. And you get JSON parsers and XML parsers and all that for free. It's a bit slow, so it might not work in all cases if you have very big performance requirements, but usually it's not really an issue. And this makes your programs easier to cross-compile because you don't need to compile the things twice, once for the native and once for the cross-compilation. So what skills you need for this? You need to know about build systems, the old one and the new one. You need to know something about how tool chains actually work because there may be interesting things that happen behind the scenes, and you need to be able to understand what's actually going on there. Code diving, sometimes quite deeply, and debugging interesting bugs. Okay, and another thing to note is that this part of the conversion process doesn't parallelize very well because you need to have pretty much all of it working until you can get anything done. So a small team of experts usually works best. If this could also be done with just one person, but if it's really big projects and it's let's say it requires a special kind of person. Many big projects have their own internal platform abstraction framework. If you're lucky, there's only one. And reporting that is the hardest bit because that's where all the gnarly bits actually are. And many have their own threading classes and so on, which are implemented both in Win threads and P threads because that's how you roll. And if you're very unlucky, you have 3 implementations, which is standard thread, P thread, and Win thread. Because why have only one? And this is one thing which you can do, which doesn't have to do with just as part of this. There's a general improvement you can do, is that if you have something homegrown, which is now available in the STL, consider replacing that as its own thing, because it's less code for you to maintain in any case. Okay, And then we get to stage 3, which I lovingly call the ditch digging phase, because it's well, let's see. So one part of this is that in addition to your own code, you probably also have external dependencies. And it might be useful to port them to the new build system as well. This depends on how your system is set up. If you use system dependencies, this is obviously not an issue for you, but for some cases it might really be worth it. If you have popular ones, they may already be available, for example, in WrapDB. And third-party dependencies are usually smaller. They're very isolated. They do one thing, and it's easier to convert them piecewise. And if you convert something that's not in WrapDB, please submit, because we accept submission and want to have as many as possible. So in the specific case of LibreOffice, to build LibreOffice core on Windows, it required 18 external dependencies. Originally, they used, this was done on Linux, they used system dependencies, so you didn't have to do this. But when the Windows porting was done, and also to Mac OS, the dependencies were added into WrapDB in the usual way. And it's interesting that it's 18, because if you contrast this to many modern languages, then what they say is that if you don't have 500 dependencies to determine if a number is even, are you even living? It's very interesting difference in perspective, because having only 18 is a lot less work. It's probably partially because the C++ standard library has lots of stuff in it, so you don't need so many small packages. But there's like a general trend of doing things in slightly larger increments, which is kind of nice. And this requires a lot of work, like actual seeding and typing, but it parallelizes quite well. And it ties in also to training, because when you have a new system, you want to train people to use it. And porting existing code requires a lot of work. So now what you can do is that you can kill 2 birds with 1 stone, where you split the work up into modules, because most projects have some sort of a modular structure, simply because you can't have 10,000 source files in one directory, or like you can, but if you have that, maybe like consider switching jobs instead. But there's some sort of modular structure there, and you can write documentation on how to port a single module from one to the other. And then you divide the work to different people so that everyone does a small part of the work. And then they become familiar with the new system, and the work gets done better. And then review and merge and do all the good stuff. And this is also even possible to automate to some degree. Again, most of the time it's possible to automate some part of the conversion with a script. So you parse the input data, which is in some format, like maybe it's a make file, maybe it's something. But usually you can fairly easily scrape the most out of it, like the biggest handwork need, and then generate that in the new thing. And then you fix what remains by hand. But there's a catch here, which programmers are prone to fall into, is that if the script doesn't work, so hey, well, I'll write a fancier script. And it's like, no, don't work on getting the script better. You can modify the original files to be simpler so that they get parsed by the simple script, and then submit that as a merge request to the original code, because it simplifies that as well. So the skills that you need for this piece, is perseverance mostly, because you just need to like keep your head down and keep doing the work, and make sure that everyone else is doing their work as well. You get to be the tech support guy or gal, because people are going to come to you and say, okay, I tried to convert this, but I had this and this problem. And this is the thing that you need to do. And then once that is done, we get to stage 4, which is the polishing. Right. So at this stage, we have a program or programs They compile and they link. It probably doesn't work. If it does work, it might not work the way you expect it to, that is correctly. So then you put on your debugging hat and then you dive and then you keep doing that until you have feature parity with the old one. And in addition, you find that there are other things which depend on things that in a ways that you couldn't think of. So for LibreOffice case in particular, they create installer packages for Windows. It's a very complicated procedure. It's Cygwin and Perl and all these sorts of things. And one of the goals that we had for the port is that you should be able to build LibreOffice on Windows using nothing but the Meson and the command prompt for Visual Studio. So you would need to eliminate both of these. And the tooling, it's a bit difficult to read. I don't know if the people who did it originally are still with the project, but the tooling assumes a lot about the layout of the build directory and a bunch of other things. And as we know, you couldn't really replicate it exactly, so you need to kind of like rewrite this probably in something more modern. So this is kind of, these sorts of work items keep popping up unexpectedly, in an unexpected way. And for this, what sort of skills you need? Even more perseverance, because things you didn't see keep popping up. But you keep doing that. If you have despair resistance, good for you. It's going to be useful. But then you get stage 5, which is called the post-polishing. Right. And the core of this is that if you have a large system of any kind, no matter how good the people who wrote that originally have been, there are some things that only work by accident. And when you change the build system, some of those things no longer work by accident. So this is an example from Godot. The port was done, it works, and at some point it started segfaulting on launch on macOS only. And this was like a bit of a head scratcher. The symptoms seemed to indicate that there was a defined mismatch between C++ and Objective C++, because the layout of things looked different in different parts of the code in the debug info when it shouldn't have, and it was completely weird. And maybe some stack corruption, because, you know, gotta love that. But it turned out not to be related to either one of these things. And then I ran it under address sanitizer, no problems were found. But then I ran it in thread sanitizer. And there were a ton of issues that it reported. But most importantly, the crashing bug went away. But it's like, okay, well, the Go problem solved, just ship it with thread sanitizer enabled. And this is like, so the tool that whose job it is to find all of the bugs and make them visible made the bug go away. Well, eventually, with this information, the duplicate issue could be found in the bug tracker. And this was a known thing. And I think people are working on fixing that. But the interesting question is that, like, why does this issue appear when you build with Meson and not when you build with the original build system, which was sconce? And the answer to that is sometimes undefined behavior means it does exactly what you want. And it was just a thing. No one knew. And these, okay, so then you have stage number 6, where everything is done. You delete the old system, and then you are free. Okay, so what have you learned thus far? Sleeves need to be rolled. It's a lot of work, which I need to do. Fun will not be had, at least during the thing, maybe later. But like in the end, it's not hard. Like it's not difficult work. It's just hard work. It's just a certain amount of effort and work you need to put in, and eventually you will succeed, because whatever your original build system did, it's it may seem like magic, but it's really not. Like it's all recreatable with more modern tools. It just takes some effort. But there you go. Then you are done. And I was a bit faster than I expected. So there's time for questions. But if you ask me a question, you also get one of these mugs. I brought 10 of them with me. I don't intend to take any of them back. So go. You already have one, but go ahead. So there's a microphone over there.
Should I take the whole thing? You may have asked for this already, but I was 5 minutes late. What were the criteria that you used to determine the new build system that you want to use? If you answered it, I can just go back to the video, but if not...
So you mean in general or for LibreOffice cases?
Yes.
So which one?
In your case.
In this case.
Yeah.
I chose Meson because I created it in the first place. So I'm not going to do anything else. But there were some discussions with the people who like LibreOffice projects and what things that they want and things that they need. And they had considered like switching, but from what I could understand, they don't have the like sufficient resources to do it themselves. So then this was like an experiment. And also, so like a scalability testing for Meson itself. So like if it fails, then like I can add the things to upstream. But I just did it because I wanted them to change to Meson, and a very selfish thing, but that's how it goes.
Did you? One thing, I've worked on large build system rewrites also, and one thing that I think everything that you said makes sense and was very much in line with my memory. One thing that we used, sort of reinvented over and over again, were diff tools. So diffing the contents of directories, diffing the contents of files. So we've written a bunch of these things, bespoke things, and more recently we've started using diffoscope. Did you? I think that was sort of like maybe one piece that was missing, or.
So for diffing like the output files, for binaries, it's not that easy because the build directory layout is different. And because of this, the object files that get generated are different. So you get all of that noise already. And you might not even compile with all the same flags because some of them are inconsequential. And then, like, how would you know it, like, if it's correct or not? And again, like these were mostly done by me on my spare time, and I don't have the resources to write a diff tool as well as do this. So this is what I had to do. But I would imagine that like if you have a repeatable build and you want the new one to be exactly the same as the old one, then that would be a good way to go.
Yeah, maybe the difference was most of our diffing was for packaging phases more than compiling phases, I think.
Right. So for like changes in the actual files themselves, or
like all the files in the RPM, all the files in a tarball, or
right.
These kinds of things. So.
Yeah, for configuration files and data files, that's fairly easy.
Yeah.
For object files and executables, okay, so executables because they're the final RPMs, that would be challenging because the people who are running the reproducible builds, who actually created diffoscope originally, like the amount of work that they have had to do to make just compiling again with the same setup be identical has been like massive. So if this existed already, then maybe. But there's just so many sources of entropy that like, okay, maybe if I could spend months on it and work on the problem, but this is not really an option.
So you were moving from Make into using Meson, right? So
yes.
Besides Meson being a lot easier to read and probably modify than Make, did you notice that your build times changed, and did they go down?
I didn't test, but like just on Windows, because I don't remember if it was this one, but there are cases where people who run Make, they invoke GCC through a wrapper executable, and on Windows just that is in slow, and all of that goes away because in Meson they're like the direct invocations.
Okay.
But I didn't do any tests, but from what I've been hearing from other people is that it's faster, and the reason is that the LibreOffice, if I think I'm correct about this, is that the LibreOffice build system uses recursive make. So it can't parallelize over directories. And because Meson uses Ninja, it can do that. So that alone is faster.
Okay, cool.
But I'm not 100% sure on that, and I didn't do measurements. And one of the reasons why I didn't do measurements is that I only build a subset, and then like how would I build the same subset with Make?
Yeah, exactly.
Yeah, but typically it's faster. But if you have something that's like, if you have a very simple CMake project and you do it with Ninja on Linux, it's not a big difference. But I haven't used any other build system like seriously for years, so I'm not perhaps the best person to ask.
Thanks.
Okay.
Right now we're using CMake, and we have a lot of dependencies, and there's lots of different package managers out there, or at least there's like Codegen and VC package, and we want to switch away from, because right now like the dependencies we do have, we build them ourselves with CMake, and we want to switch to either like VC package or Codegen. And is that something that Meson supports, or is it only WrapDB?
We support. So the goal is that we intend to support all dependency provider systems. So if there's a way for the system to tell you that this is the dependency X, then that's what we use. So currently we have package config, which is the main one. And I haven't used Codegen myself, but I know that they have some sort of integration. And for VC package, I don't think I've tried it myself, but I know that people are using it. And like anything that can provide package config files, it works because that's the default one. For the other ones, I don't know exactly.
So as long as Codegen can export in a package config file, then I should be able to use it.
It should work.
Perfect.
You mentioned at the beginning of the talk that you ported some part of Unreal Engine. If I remember correctly, most of its build system is C#. So how did you go about doing some of the more complicated parts of that? So I found C# to be quite difficult.
So I didn't do like okay. For those who don't know, so Unreal Engine has a build tool called Unreal Build Tool, which is the thing that they use to build. And it comes as a C# executable. And its source code is probably somewhere. I didn't try to look it up. And the way they set this up is like it's like snippets of C# or something.
Yeah, there's some stuff in the top level project, but a lot of it's somewhere in Unreal.
Right. So in this case, I followed my own instructions and I didn't try to understand what it does. Now, I couldn't find a command line switch for Unreal Build Tool to run in verbose mode. And this was another, like, it may have that they typically do. I just couldn't find it. But so then I just like looked roughly at, okay, so this seems to be doing that. I'll just take the same files and try to compile. And it worked fairly well up to a point. But then I just, the problem with Unreal Engine is that because it's closed sourced, I can't put my code out there for people to view, which I would really like to do, but unfortunately I can't. And then it's just a question, okay, I can do this alone at my house for a while, but then at some point you just lose interest, which is unfortunate. But so Epic, if you want to change your build system to something better, you can contact me.
Oh, thanks for Meson.
so many hours of work.
All right. Well, it's good to know. So it wasn't mentioned in the you were using the microphone, so I was asked to repeat. So there was a thank you for saving a lot of effort. Right. As an interesting side note, so at CPP, I think it was in CppCon the last time I was there, or the previous time, is that there was a person who came up to me, and they were working on a game, or had worked on a game a few years earlier that used Unreal Engine, and they shipped it. And unfortunately, I can't remember what the name is, but it shipped and it ran on Windows and so on. But they had a backend service which ran on Linux, and it might have even been Unreal Engine 3. But no newer than 4. And they told me was that they ported Unreal Engine to build with Meson because Unreal Build Tool was so terrible. Their words, not mine. So the first AAA game that has ever shipped with Meson build files was actually done with Unreal Engine. So there's a piece of trivia for you. All right. Any other questions?
So, for building on Windows, does it support building with CLR? With the C language or runtime or something like that? It's like to be compatible with the .NET framework?
I haven't tried it, but so we do support compiling C#. And I know that there are like commercial applications that have shipped that have built their like C part. They're using the GStreamer framework, so they used that, and they had their C# thing on top for the UI. And this is an application that they have shipped that was built completely with Meson, and so it's out there. But I haven't done any C# development myself, so I can't comment on the details.
Thanks.
But again, our goal is to support all of those, so patch is welcome, I guess.